With absolute value equations, remember that there can be two solutions, there can be one solution, and sometimes there's no solutions. Today we're going to continue with solving absolute value equations. The only difference is now we're going to have variables on the right side of the equation. And that kind of throws a wrench into things, but we can deal with it. So, the equation is the absolute value of x plus 1 equals 2x. It's kind of hard to think about being 2x units away from 0, but I want you to remember the pattern that we followed previously. We're going to set up two equations. The first equation is x plus 1 equals positive 2x. Notice I wrote it without absolute value bars. The other equation is x plus 1 equals negative 2x. So set up two equations. The first equation exactly as it was written without the absolute value bars. The second equation, take the right side, the side that didn't have absolute value bars, and take the opposite of it. The absolute value bars denote how far something is from 0, but now that it's 2x instead of 2, it's harder to think of it as like 2 units from 0. It's 2 times x units from 0. It just makes it a little more complicated. So the pattern is write two equations, one of them being positive 2x, the other negative 2x. We're going to solve both of these equations. And I'm going to solve this equation by subtracting x on both sides to get 1 equals, what is that, 1x? So x equals 1. That's one of my solutions. The other equation, I would subtract x on both sides. So x equals negative 1/3. When there's a variable on the right side of the equation, it brings the possibility of extraneous solutions into play. An extraneous solution, I'm going to write that up here. An extraneous solution is simply an extra solution. In the process of solving the equation, we end up with two solutions. But as we know from Friday, some of these absolute value equations do have two solutions, but some of them only have one and some of them have none. So we have to take these two solutions and decide which of them are actually solutions and which of them just appear to be solutions. An extraneous solution appears to be a solution because we solved the problems correctly, but it doesn't actually work. So we need to plug these solutions back, not into the green equation that we created. We need to plug these solutions back into the original equation with the absolute value bars. Okay, 1's going to be pretty easy. Plug in 1. What is 1 plus 1 in the bars? 2. So inside the bars, we'd have 2. What is 2 times 1 on the right side? 2. Does the absolute value of 2 equal 2? Yes. Maybe it'll let me write. So I plugged 1 into this equation, the absolute value of x plus 1 equals 2x, and it gave me the absolute value of 2 equals 2, which is a true statement. So x equals 1 is a solution. Now let's try negative 1/3, and you're totally fine using calculators for this. So negative 1/3 plus 1 is 2/3. So we'd have the absolute value of 2/3. 2 times negative 1/3 is negative 2/3. Does the absolute value of a positive number equal a negative number? No. That's an extraneous solution. So because that doesn't work, negative 1/3 appears to be a solution because we solved the problem correctly, but it doesn't actually work in the original problem. Let's try the next one. The first equation is x equals 2x plus 3. Recopy the equation without the absolute value bars. That's your first equation. Your other equation is the stuff from the absolute value bars, x, equals, we need to take the opposite of the right side. Anyone want to take a guess what the opposite of the right side is going to be? Negative 2x minus 3. So take the opposite of both terms. Okay, now take a moment, solve both equations. Okay, once we get the apparent solutions, negative 3 and negative 1, we need to test these out. We have to test these out back in the original equation that has the absolute value bars. If you plug negative 3 into this green equation, it's going to work because that's where negative 3 came from. If you plug negative 1 into this green equation, it's going to work because that's where it came from. You have to plug them back into the original equation. So, in the absolute value bars, we plug our x in. Absolute value of negative 3. What is 2 times negative 3? Negative 6 plus 3. So that gives me the absolute value of negative 3 equals negative 3. Is that a true statement? No, absolute value has to equal a positive number. So, that is not a solution. Now, just because one of your solutions doesn't work does not necessarily mean that the other solution will work. There's a chance that there's no solutions. But let's check. So we put the negative 1 into this equation. We'd have absolute value of negative 1 equals 2 times negative 1 is negative 2 plus 3. Does the absolute value of negative 1 equal positive 1? Yes, that is a true statement. So x equals negative 1 is our solution. In number 3, first thing we need to do is write our two equations. The first equation is exactly as it's written without the absolute value bars. The other equation, we write the stuff from the absolute value bars equals the opposite of the right side. And now we solve both equations. Once you get the solutions 4 and 4/3, first of all, are those the solutions you got? Okay. We need to plug them back in. Do not plug them into the green equations. We are plugging them back in to the original equation. So 2 times 4 is 8. 8 minus 4 is 4. So we plug 4 in right there. 2 times 4 is 8. 8 minus 4 is 4. And on the right side, x is 4. Does the absolute value of 4 equal 4? Yes. So x equals 4 is a solution. For 4/3, you're going to need to plug this into your calculator. 2 times 4/3 minus 4, I believe, is negative so negative 4/3, or negative 1.3 repeated, equals 4/3. Yes, that is true. So that is also a solution. So just like on Friday, some of these have 2 solutions, some of them have 1 solution. Some of them might even have no solutions. In number 4, I want you to think about what we need to do before we set up 2 equations, because there's one step that needs to be done before we set up the 2 separate equations. Got to get the absolute value by itself. So our first step is to subtract 8 on both sides. Someone in another class said combine like terms. Well, you can't combine the -6 and the 8 because the -6 is inside the bars and the 8 is not. So move the 8 to the other side by subtracting 8 on both sides. So we have the absolute value of x minus 6 equals 3x minus 4. Now, on your own, set up 2 equations, solve both equations, plug them in, see which ones work. My 2 solutions are -1 and 5/2, or the decimal 2.5. When you plug these in, our first step, when we subtracted 8 on both sides, did not affect the absolute value bars. So to make this easier, we can plug our solutions in here, because we still have absolute value bars there. You have to plug your solutions in wherever you still have absolute value bars. So, move back down here. -1 minus 6 is -7. 3 times -1 is -3 minus 4 is -7. Does the absolute value of -7 equal -7? No. 5/2, or 2.5, I would probably use 2.5. 2.5 minus 6 is, I believe, -3.5. Is that correct? Okay. 3 times 2.5 is 7.5 minus 4 is 3.5. Right here. Where the purple arrows are. Does -3.5 in absolute value bars end up equaling +3.5? Yes. So that is our solution.